All right, so the next question reads, if A1 is an arithmetic sequence and B1 is an arithmetic sequence, show that the addition of these two sequences is also an arithmetic sequence. Okay, so first of all, I'm going to state what an arithmetic sequence is. Arithmetic sequence is arithmetic. Yeah. So arithmetic series is basically a sequence of numbers that follows a pattern. Okay, so a sequence of numbers is basically S1, S2, S3, and each of the terms in the sequence are related to another one, to the previous one and to the first term. And the relation that an arithmetic sequence has is that each term of the sequence, the next term of that sequence is just the previous term plus a common difference, or D. Okay, so if we had our arithmetic sequence S1, S2, S3, S4, dot, 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 Sn, right? Then if we were to think about it as a arithmetic sequence, we have S1, then we have S1 plus common difference D to be S2, S2 plus common difference D is equal to S3, and so on and so forth. Okay, so the nth term in the arithmetic sequence is going to be Sn minus 1 plus D. Okay, so another way that we can describe an arithmetic sequence is if the difference between the consecutive terms are the same. Okay, so what does that mean is that, let's say that in an arithmetic sequence, the difference between the second term and the first term is D, but that's also equal to the difference between the third term and the second term. And if we want to extrapolate further, that's also equal to the difference between the nth term and the nth minus 1 term. Okay, so that's another way that we can describe an arithmetic sequence. That the difference between two consecutive terms, so Sn and Sn minus 1, is equal to the common difference. So all the differences between consecutive terms is going to equal the common difference. Okay, so now that we have described what an arithmetic sequence is, we can now attempt to prove that the sum of two arithmetic sequences is also an arithmetic sequence. Okay. So basically, how we're going to solve this is that we want to show that A1 plus B1, that the consecutive terms within the sequence has the same common difference. Okay, so first of all, we know that A1 is an arithmetic sequence, right, stated by our question here. So that means that A1, A2, A3, dot, 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 AN. Okay, that means that according to our definition here, the nth term of our sequence minus the n minus 1 term is equal to our common difference. Okay? Now, same thing with B1, all right? Our sequence B1 with B1, B2, B3, dot, 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 to Bn. The difference between the Bnth term and the Bn minus 1 term is also equal to, let's say, a different common difference, which is, I guess, E. Okay? So these are two known facts about this, okay? Now, let's consider the sequence of A1 plus B1, right? So what is that going to be? So the sequence of A1 plus B1 is going to be A1 plus B1 as our first term, A2 plus B2 as our second term, A3 plus B3, and dot, 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 AN plus BN. Okay, so we need to show that the difference between these consecutive terms is going to have a common difference. Okay. All right. So let's first think about the difference between our first two terms, right? So A2 plus B2 and A1 plus B1. Okay. So if we were to think about the difference between A2 plus B2 and A1 and B1, what would we get here? Okay. Well, we could rearrange this, right? So if we were to break it out of the brackets, we would have A2 plus B2 minus A1 minus B1, right? And we could rearrange this in a different manner, right? We can rearrange this to be A2 minus A1 plus B2 minus B1. Okay? And according to our sequences here, right, A2 minus A1 is going to equal to D, and B2 minus B1 is going to equal E. Okay? So this is the common difference between the first two terms, right? So now we have to show that the common difference between the next two terms is the same, and so on and so forth, so on and so forth, okay? So let's check A3 plus B3 minus A2 plus B2, okay? So if we do this for the next two consecutive terms, if we rearrange it again, right? So we can say this, if we break through the brackets, we have A3 plus B3 minus A2 minus B2. And if we rearrange it, we get A3 minus A2.
3 plus 33 minus 18.
Sorry, that's my series. Okay, A3 minus A2 plus B3 minus B2. Okay, so A3 minus A2 is again D, and B3 minus B2 is again E. So the third term and the second term, the difference between them has the same common difference as the difference between the second term and the first term. Let's check about this in general, right? What about if we check it in general? So let's have an nth term, right? Let's say what's the difference between the nth term of our sum of the series sequences, right? And the nth minus 1 term, right? Okay. So if we break through these brackets again, I'm not going to write it out too much. I'm just going to skip to the third step here. So we have an minus 1, right? Plus bn minus bn n minus 1's term, okay? So here, if we can look at our sequences here, they have the same common difference again, right? An minus 1 is D, and the common difference for bn minus 1 is E. So we have proven that in general, the common difference of our sum of the sequences is equal to D plus E. And since it is consistent across all the terms, we have shown that the sequence of A1 plus B1 is also an arithmetic sequence. So therefore, A1 plus B1 is an arithmetic sequence. Okay. So whenever you're trying to prove any of these kind of questions where it tells us to prove, you always want to try to find the general case, right? Because here, these are specific cases, right? And there might be sometimes a specific case that might not follow this rule, right? But if you solve for the general case, and the general case gives you a consistent answer, then you know that your proof is correct. And in this case, we solved the general case, and we found the common difference for the sequence of A1 plus B1, which is D plus E. Okay? So this solution is correct. Good work. And the last thing I'm going to touch on is that there's multiple ways of proving